Okay, here goes lesson 1-5. Hopefully, this sound is better, and off we go. I am going to do some 1-4 to begin with, and then mostly 1-5. The 1-4 part is the extraneous solution part, and that is we're going to solve absolute value problems which might have extraneous solutions. What that means is answers that don't work. Okay? So again, those are the 1-4 types of problems that we'll be working on, solving more absolute values. But once in a while, you're going to get an answer, you check it, and it doesn't work. Doesn't mean that you didn't make a mistake. It just means that it's an answer which we cannot accept because it doesn't work back in the original problem. The second type of problem that I'll be doing today is from 1-5. This is the 1-5 part, is solving literal equations. And you'll be doing many of those. So make sure you write down that word, literal equations, and what it means is to isolate a variable among many variables. Okay? So you won't just have a single variable you're getting by yourself, but you'll have lots of different variables, and you've got to get one of them itself. Here goes example number 1. Solving absolute value equation. In this case, it says the absolute value of 2x minus 19 equals 4x plus 1. Make sure you copy that down on your note sheet. And again, I have 2 arrows because one is the easy problem and the other one is tricky. And what I mean by that is that we need to take the opposite of what we think it is. This one is what it is, so it's just what you see, minus the absolute value, of course. 2x minus 19 equals 4x plus 1. Notice again, the absolute values are dropped, so now we can go ahead and solve for x. In this case, I'm going to subtract 2x from both sides to put my like terms together. This gives me 2x on this side. The plus 1 is here, and the 19 is left on the other side. Don't forget, it is a minus 19, which means that the 19 is a negative value. Isolating further, the x, we drop the negative 1 by adding negative 1 to both sides, and I get 2x equal to negative 20. Finally, my last step, cancel the 2 by dividing by 2. Okay? And we get an answer of negative 10. Okay? Before I circle that, I need to be careful because I need to check the negative 10 back in the answer. So I'm actually going to erase that box and we'll check it. But let's first of all go ahead and work on the other tricky problem over here. Okay. Again, the 4x plus 1 is going to stay as it is. We don't flip that. It's the 2x minus 19 that we need to flip up. And so we put a negative sign in front of that. And again, distributing that negative sign to both of these terms, we get negative 2x plus 19. And again, that equals 4x plus 1. Now we proceed to solve this as an algebra problem, just like we've solved other algebra problems. Again, collecting our x first, we always want to focus on that piece. So in this case, I'm going to add 2x to both sides. That gives me a 6x here, plus a 1, and the 19 is here. Then I would subtract 1, or add negative 1 to both sides. giving me 6x equals 18. And dividing both sides by 6 gives me a final answer of x equals 3. All right. Now I'm going to take these problems back to my original equation, which said the absolute value of 2x minus 19 equals 4x plus 1. And I'm going to replace x with each one of these answers. All right. We plug the negative 10 in for x. There and there. So we get the absolute value of 2 times negative 10 minus 19, 4 times negative 10 plus 1. Doing the right side looks a little bit simpler, so negative 40 plus 1, I think that gives me negative 39. In the left side, I get negative 20 minus 19. I'm going to take the absolute value of that. Once I subtract those two things, I think I get negative 39. And the absolute value of that is 39. We can clearly see that negative 39 does not equal negative 39. And so this answer, x equals negative 10, appears to be a bad answer. Okay, it doesn't work. So we call it an extraneous. Sorry, my dogs are growling in the background. All right, I'm now going to come over and check 3 into, again, the same spots. Hush. I'm working, Loki. All right, so the absolute value of 2 times 3 minus 19 equals 4 times 3 plus 1. So 12 plus 1 is 13. 2 times 3 is 6 minus 19. I want to take the absolute value of 6 minus 19, which I think is negative 13. And in fact, that does equal 13. So this worked. So my answer to this problem, even though I get 2 problems, is x equals 3, not x equals negative 10. All right, well there's... Okay, this next example won't be as long. We are going to be solving a literal equation, and for our first problem here, we're going to be solving for y. And what that means is we need to get this y here by itself. To do that, we need to get rid of 2 pieces. I need to get rid of the 2x, and I need to get rid of the 4. Careful, that is a negative 4. Yeah? So the y is going to stay there by itself. The first thing I do is I cancel the 2x. Okay? It is connected to the 4y with a minus. Now be careful, that minus affects the 4, and so the 2x is positive. The temptation is to add 2x, but we need to add negative 2x to both sides. All right? Here's where things get just a little tricky. On the left side here, notice the 2x's cancel each other. Yeah, one's negative, one's positive, so they're gone. We get 0 here. Oops, didn't mean to do that in red. 0 plus negative 4y, which is just negative 4y, right? Now on the right side, don't be tempted. You cannot combine these two things. They are very different, because one's got an x. So don't say things like 18x. Leave it as 20 plus negative 2x. Okay? All right, the last thing I need to get rid of is that negative 4. It is attached by multiplication. So to undo that, we divide by negative 4, and that means we need to divide the right side by negative 4. Now, yes, y is by itself. When you divide the left side, you have to divide both sides of the equation by negative 4. What that means is I have to divide the 20 by 4. I have to divide the negative 2 by 4 as well. Okay? So, 20 divided by negative 4 plus negative 2x divided by negative 4. Simplifying those two expressions, I get negative 5 plus 1/2 x. That x can be put with the 1, or it can be put off to the right and just thought of as a multiplier times the 1/2. It's probably a better way to think about this particular problem. All right. Last, I want to do one more. That's another little equation. So this could be thought of as example 3. And this one is going to be something of a formula. So it's not just x's and y's, but 2 times the width plus 2 times the length. I'm going to use a cursive L for my length because just a plain non-cursive L looks like a 1. And that equals the perimeter. And I'm going to solve this problem for W. Okay, I'm going to get W by itself. And every problem will say solve for a particular variable. All right, that means I need to get rid of the 2 in front of the W. I need to get rid of the 2L. Yeah? Same process as we just did in the last problem. I'm going to add this piece first. Again, don't try to combine the right side. That's just P plus negative 2L. On the left side, we have 2W. That's left. Yeah? Because the 2L's canceled. Again, getting rid of the 2. I'm going to divide that by 2. I'm going to divide both of these things by 2. So the 2's cancel, leaving me a 1W. And then over here I've got P over 2 plus negative 2. Again, I tell kids they have to feel the love because you got to draw a little heart because the 2 divides into both parts. So we get a negative 1L. And again, you could write that as just minus L. Different ways to express that, but probably negative 1L is the best way to do that. And here now is our problem. We have solved the little equation for W. Again, we solved this one up here for Y. And that is your lesson. Thanks. Good luck in the work.